Welcome back and a very good evening. So this is your part 2 of the study of modern periodic table. In part 1 we have talked about the variations across groups and periods. So in part 2 what we are going to be doing is we are going to study the various trends of properties down and left to right in a period. Okay, as we told in part 1 also, I'll give you a quick recap that in a periodic table we make two moves down the group where we are increasing the shells by 1, and left to right in a period where we are increasing the valence electron number by 1 but not increasing the shell. And one more thing, in these topics we are not talking about this whole group number 3 to 12 and these last two. We are ignoring this. Okay, we are just studying this because these will be dealt in class 12, so I will make a separate video on this later. Okay, now before we proceed, there is one bit of information I would like to give again. The first two groups are called the S block. S block. Okay, why is it called the S block? Because the final electron enters the S subshell. Now subshell concept is a concept of class 11, won't be dealt with in class 10. So I'll make separate videos on it. So those who have already learned class 11, they will understand that the first two groups are S block. Group number 13 to 18 is called the P block because the final electron enters the P subshell. Group number 3 to 12 is called the D block because the final electron enters the D subshell, and these last two are called the F block because the final electron enters the F subshell. Now this D, S, P and F basically are electronic configurations only. They are subshells inside a shell. For this, which you have to understand the quantum model of the atom. It's a class 10 level, a class 11 level, so for 10th level you can ignore this part. Okay. Alright, now let's begin with the class 10 level study, which is again important for class 11. So just see this now. So the first trend we will be taking up in the periodic table is your atomic size. समझते हैं इसे? Atomic size. Now what is atomic size? Atomic size, if I draw a Bohr model of an atom, suppose this is an atom. इसमें दो shell है and there is a nucleus. So what is the size of this atom? The size basically is one thing. I'll just draw the shell with this. This size basically is nothing but distance of this nucleus to the final subshell, final shell. This is the radius. इसको एक sphere मान लो. So sphere के center से sphere की boundary तक जो distance है, that is the radius of the sphere. So this is the radius of the atom. And from this radius, if we use the formula of area, because this is actually not a complete sphere, so we will not write the formula of pi r square here. Whatever the formula of area is, we'll include, and that area is your atomic size. Okay, so basically we can define atomic size as the area which is enclosed in the atomic radius of an atom. Atomic radius is defined as the distance of the nucleus to the last valence shell, or the valence shell is the atomic size. Now size of atom is very small. We cannot measure it in meters. So one unit which we use for size of an atom is PM. PM is not for Prime Minister, PM is for picometers. Okay, so just revise this once again. What we have understood, that atomic size is the area enclosed within the atom, which can be determined from the formula of its atomic radius. Now atomic size is a very small quantity, so hence we do not measure it in meters. We use the unit of picometers. Okay, picometer is 10 power minus, okay, I'll write it here. So 1 picometer is equal to 10 power minus 12 meter. So you can see it's a very small quantity. Okay, 10 power minus 12 meter. Fine, is 1 picometer. This is a conversion. Alright, so now let's talk about how atomic size varies across the period and down the group, because I told you we can make only these two variations in the periodic table. So the first one is down the group. Now when I move down the group, as we remember, as I told you in my previous video, that down the group the number of shells increase by 1, whereas the number of valence electrons is same, because जब हम नीचे जा रहे हैं we are actually crossing periods. Is that okay? Fine. So जब हम नीचे जा रहे हैं shell बढ़ रहे हैं, and what we saw that atomic size basically is the distance of the nucleus to the shell, And suppose I have this atom which is having only 2 shells. This is the size. And if the radius, if I have this atom which is having 3 shells, this is the radius. Which is larger? This is larger. तो यानी radius बढ़ता है तो क्या होता है? Size बढ़ जाता है. So when I am moving down the group, the size is increasing. So size increases down the group. Why? Because the number of shells increases. Shell बढ़ेगा तो distance बढ़ जाएगा and the size will increase. One more reason for this is, in an atom, if we talk about, there are two types of charges: the positively charged nucleus due to protons, neutrons are neutral, and the negatively charged electrons. Opposite charges attract each other, so the proton and neutron will attract each other like this, and hence the charge which the atom will face from the nucleus will be the effective nuclear charge, okay, and will have a force of attraction. The nucleus will have a force of attraction on the electron, and as the force of attraction will be large, the size will be small. तो जितने हम शेल्स बढ़ाएंगे उतना ही फोर्स ऑफ अट्रैक्शन कम हो जाएगा, क्योंकि इलेक्ट्रॉन्स दूर होते रहेंगे. Okay, that's one thing we can take up. So I'll just explain it with the help of your the diagram once again. So this nucleus which is there in the atom is positively charged, और इसके आसपास घूम रहे हैं electrons which are negatively charged. So this is negative and this is positive. Okay, this is attracting this. There is an attraction. Okay, जिससे size छोटा हो रहा है. But when we will increase the shells, and suppose I have an electron here, so what the attraction will be on this electron will be much less, because there will be too much of distance, and also the inner electrons will shield this outer electron. ये इसको बचा लेंगे size. तो force of attraction कम हो जाएगा, and if the force of attraction will reduce, we can see that the size will reduce. Okay, sorry, will increase. So hence when we compare it down the group, we can see that the size increases because of increase in distance. And second thing is, as the distance is increasing, the effective nuclear charge and the nuclear force of attraction in the atom is also decreasing. So hence the size is increasing. Okay. Now the second thing is when we move left to right in the period, like this. I am moving here. Okay, left to right in the period. Now when I am taking this kind of a movement, what I am doing is, left to right in the period में we know that the shell is same, distance बढ़ नहीं रहा है, पर क्या हो रहा है कि electrons are increasing, because group number is increasing, so electrons are increasing. So as we are increasing the electrons, so you can just see in this diagram once again, मैंने यहाँ पे I have increased more electrons. Okay, I have taken up more electrons here. I have increased the electrons in this shell as well. So if I am increasing the electrons and I am keeping the shell number constant, this nucleus will attract all of these electrons with a much greater force, because in सब पे nucleus का force लग जाएगा. Okay, and then what will happen? The force will increase and the size will reduce. So hence what we can conclude is, left to right in a period, the number of shells remains the same, but the valence electron increases because of increase in group number. उसकी वजह से the effective nuclear charge and the nuclear force of attraction per electron is also increasing, and if that is happening, the size is decreasing. Okay, so hence what we can conclude here is, the down the group the size increases due to nuclear force decreases and shell is also increasing. But whereas if we compare it with the left to right in the period, like this, if we move, the size decreases, nuclear force increases, and the shell is same, but the valence electron increases. And because of this increase in valence electron, the nuclear force is also increasing. You can take a screenshot of this. This is the summary. Okay, just wait, one more result is important. The final result which we get is, size is inversely proportional to the nuclear force. More will be the nuclear force, more will the electrons be bound together, and less will be the size. Okay, so this trend of size is inversely proportional to the nuclear force holds good for all kinds of atoms, and hence is a very important and desired result. Fine. Now moving on to the next trend. This was the first trend on size. So let's move on to the next trend, which are depending on size, the metallic and non-metallic properties. Okay. Okay. So let's talk about metallic properties. Again, we'll be comparing it down the group and left to right in the period only. Okay. अब देखिए, down the group as we have done, the size will increase, and left to right in the period when we will move, the size will decrease. Now, metallic property if we talk about, so just see that these 2 points are only important, size ka, and then if we talk about the metallic property. Okay. So if we are talking about the metallic property, what is metallic property? Metallic property basically is the tendency to lose electrons. Metals have the tendency to lose electrons and hence are electropositive in nature. So hence metallic property is also the tendency to lose electrons and become electropositive in nature. Okay, that's what it is. Now how will electron losing be easy? Electron losing will be easy if the size is large, because the nucleus, as I told you, again I'll show you the same diagram, the nucleus is putting a force of attraction on the electrons, isn't it? So if the size is large, that means electron is a lot away from the nucleus and the force of attraction of the nucleus will be very less, because size is inversely proportional to nuclear force. So the tendency to lose this electron will be easy. The electron will be lost easily and hence the metallic character will increase. So what I can conclude here is that the metallic character down the group is high. So metallic character is high down the group. Why is that? Because down the group the size is increasing, and because size is increasing, the nuclear force per electron is decreasing, and as the nuclear force per electron is decreasing, it is very easy to lose that electron, and losing electron is the metallic property. Converse for the left to right in the period. Left to right in the period, size is decreasing, and if size is decreasing, electrons nuclear force will be increasing. That you understand very well by now, we have explained it. And because of that, tendency to lose electron will be very, very weak, and as tendency to lose electron will be weak, the metallic character will decrease. So hence the final result which we can give here is that metallic character is proportional to the size. Okay, metallic character is proportional to the size, and that's why down the group it increases, and left to right in a period metallic character will decrease based on the size alone. Okay. Now if I talk about the non-metallic character, non-metallic character means the tendency to gain electrons. Non-metal means the tendency to gain electrons and become electronegative, isn't it? Non-metal, metal का उल्टा, it is inversely proportional to metal, है ना? So if metallic character will increase, non-metallic character will decrease. If metallic character will decrease, non-metallic character will increase. So same thing here also. So if I am having metallic character increased down the group, that means the non-metallic character will be decreased down the group, and hence the non-metallic character will be increased down the left to right in the period, because the metallic character is decreasing. जितना एक element is preferring to become a metal by losing electrons, जितना वो tendency कम होगा, the element will prefer to gain electrons and become a non-metal. So hence metallic character is inversely proportional to non-metallic character, and hence down the group it decreases, and across a period it increases. Okay, that is very, very important, and because that's why one more result we can draw from here, size is proportional to metallic character, that means, and metallic character is inversely proportional to non-metallic character. So from which we can confer that the size too is inversely proportional to non-metallic character. Okay, that means जितना size बढ़ेगा उतना metallic character तो बढ़ेगा, और उतना ही non-metallic character will be reduced. So the smaller size prefers a better non-metal. Okay, so if I have a smaller size, I will prefer a better non-metal. Okay, is the result. Now based on this, there is one more line with which I will conclude this part, is that where do I find the best metals? I will find the best metals, if I go left to right in a period, I will find the best metals in the left. So metals will be found in the left of the periodic table, because across a period the non-metallic character बढ़ रहा है. And if I go down the group, नीचे जाना metal के लिए बेहतर है. So I will also find great metals down the group. So left and down is the position for the good metals. Okay. And if I talk about non-metals metal का उल्टा. Across a period non-metallic character बढ़ता है. So I will get non-metals, best non-metals towards the right. Okay. And also I will get the best non-metals towards upward side, because नीचे जाने में metallic character बढ़ रहा है. So non-metallic character ऊपर जाने में बढ़ेगा. Okay. So this is two things with which I will leave you. But one exception, when I am talking about left to right in a period, I am always ignoring this group of noble gases, because the last group is a group of noble gases which is not affected by these properties. Fine. In my next part, part 3 of the periodic table series, we will be talking about noble gases and some special groups and trends in the valency and valence electrons across groups and periods as well. And then I'll take you through some questions as well. Thank you. Please like, share and subscribe. And do write in the comment section whether if you have any doubt or if there was any shortcoming in the video. We'll be glad to improve it. Thank you.